The assessment of the severity of local impact on a pro-bionic composite lattice shell by the use of fiber optic sensors. The subject is a pro-bionic lattice shell, which is the newest concept of the airplane body with reduced weight. There is UD-CFRP ribs substructure covered by thin aerodynamic skin. Low-velocity impacts by foreign objects can damage ribs and create problems. Can we protect the ribs with special tabs made of thermoplastic? Is it possible to use embedded fiber optic sensors to assess the severity of the impact? Does the rib and fiber optic sensors keep integrity during low-velocity impact of 50 joules? How high there will be the residual strain recorded by fiber optic sensors? To solve the problems, we used finite element analysis. First stage, full shell, smooth with stiffness equivalent to ribbed one, low velocity impact, explicit formulation. Results: maximum contact force and local displacement to put boundary conditions for detailized fragment. Second stage, detailized fragment, implicit formulation, to get stress-strain state during loading, unloading, and recording the residual strain of tap, fiber optic sensor location. To estimate the possibility of getting damages in the rib, we used loading and unloading of the fragment. Because the tap was made from elastic plastic material, we have seen the residual stresses and strain in the tap. The fiber optic sensor being implemented into the tap will show enough signal to register the place of impact event and possibly the energy of the impact, having preliminary given the calibration curve strain versus energy. See full paper. It was found that the placement of the fiber optic sensor for recording residual strain in the impact zone should be in the upper part of the tap at the contact with the skin. When the impact energy decreases from 50 joules to 5 joules, the residual strain in the tap decreases monotonically from 2.07 to 0.57%. To register a residual strain near the local impact place, which isn't known before, it is better to use a distributed Brillouin fiber optic sensor rather than Bragg's one, which need to know exact placement of grid to strain measurement. Thanks for your attention.